Hi everyone, this is Srilata. Today I would like to teach solving of linear equations in matrix methods. Here I am using three types of methods. In these three types of method, we get the same values of three variables x, y, z. Here are the three variables x, y and z. The first equation is x plus y plus z is equals to 1, and the second equation is 2x plus 2y plus 3z is equals to 6, and the third one is x plus 4y plus 9z is equals to 3. So first method I used here, Cramer's rule. This is Cramer's method or Cramer's rule. In this Cramer's rule, we write the coefficients of x, y, z in matrix A. So A is equals to, the three coefficients are 1, 1, 1, and second equation is 2, 2, 3, and in the third equation 1, 4 and 9. This is the matrix A. And matrix X is equals to, the three variables, those are x, y and z. And the matrix B is equals to, the three values, those are 1, 6 and 3. Now we want to find out the determinant of first matrix. How we can find out the determinant of A matrix? Determinant A is equals to, this is 3 by 3 matrix. So first element 1 of, remove this row and this column to get 4 elements, 2, 3, 4, 9. The 4 elements determinant is 18 minus 12. Now minus 1 of, second element is 1, minus 1 of, again this row and this column is eliminated. Now 2, 3, 1, 9. The 4 elements determinant is 9 to 18 minus 3 plus last element is 1, 1 of, remove this row and this column to get these 4 elements. The 4 elements determinant is 4 to 8 minus 2. 1 of 18 minus 12 is 6 and minus 1 of 15 plus 1 of 6. 1 into anything to get the same number, that is 6 minus 15 plus 6, that is equals to 12 minus 15 is equals to minus 3. This is the determinant of A. Now we want to first find out the first variable, that is x. X is equals to delta 1 by determinant of A. What is delta 1 here? Delta 1 is nothing but, in this A matrix, the x coefficients are 1, 2 and 1. Instead of, we want to remove that, instead of these three values, we write this one, 1, 6, 3. Now remove the three x coefficients. Instead of these coefficients, we write 1, 6, 3. And y coefficients are same and z coefficients also same. By determinant is minus 3. Again, we find out the determinant of delta 1. So delta 1 determinant is, delta 1 is equals to 1 of, remove this row and this column to get 9, 2, 3, 4, 9. These 4 elements determinant is 18 minus 12. Now second element has minus symbol, minus 1 of, remove this row and this column to get 54 minus 3 3s are 9. Now last element, that is plus 1 of, remove this row and this column, 6 4s 24 minus 3 2s 6. Now 1 of, 18 minus 12 to get 6 minus 1 of 45 plus 1 of 18. 6 into 1, 6 minus 45 plus 18, that is equals to 8 plus 18 plus 6 is 24 minus 45, that is equals to minus 21. So determinant of delta 1 is minus 21. So substitute in that, x is equals to delta 1 by determinant of A, that is equals to, delta 1 value is minus 21 by minus 3. Minus minus cancel, 3 in 27, 21, 7 times. So x is equals to 7. The first variable x value is 7. Now we want to find out the second variable, that is y. Y is equals to, automatically formula is delta 2 by determinant of A. What is delta 2 here? In this A matrix, the y coefficients are 1, 2, 4. Instead of y coefficients, we write 1, 6, 3. remaining x coefficients are same and z coefficients are same. So first coefficients 1, 2, 1 as usual. Instead of y coefficients we write 1, 6, 3, 1, 6, 3 and z coefficients are same as 1, 3, 9 by determinant of A is minus 3. Again determinant of delta 2 is equals to same 1 of remove this row and this column to get these 4 elements determinant is 54 minus 9. Now minus 1 of remove this row and this column, second row and first row and second column we remove to get 2, 3, 1 and 9. The 4 elements determinant is 18 minus 3 plus 1 of remove this row and this column. So 2, 6, 1, 3 determinant is 6 minus 6. Now 1 of 45 minus 1 of 15 plus 0. So 1 into 45, 45 minus 15 is equals to 30. Substitute delta 2 value in that equation. So y is equals to delta 2 by determinant of A, that is equals to delta 2 value is 30 by determinant A is minus 3. On cancellation to get minus 10. So y is equals to minus 10. The second variable value is y is equals to minus 10. Coming to the third variable, that is z is equals to delta 3 by determinant of A. What is delta 3 here? Delta 3 in this A matrix, the z coefficients are 1, 3 and 9. So instead of z coefficients we write 1, 6, 3. So x coefficients are same 1, 2, 1 and y coefficients are same 1, 2, 4. Instead of z coefficients we write 1, 6, 3 by determinant of A is minus 3. Now we want to find out the determinant of delta 3. Delta 3 is equals to 1 of remove this row and this column to get the 4 numbers 2, 6, 4, 3 determinant is 6 minus 4, 6 are 24 minus 1 of remove this row and this column 2, 6, 1, 3 determinant is 2, 3 are 6 minus 6 plus 1 of remove this row and this column 8 minus 2. 1 of minus 18 minus 1 of 0 plus 1 of 8 minus 2 6 minus 18 minus 0 plus 6 minus 18 plus 6 to get minus 12. Substitute delta 3 value here. So z is equals to delta 3 by determinant A. Delta 3 value is minus 12. Minus 12 by determinant A value is minus 3. So minus minus get cancelled. 3 is possible here 4 times. Therefore z is equals to 4. These are the three variable values. X is equals to 7, y is equals to minus 10 and z is equals to 4. Therefore x is equals to 7 and y is equals to minus 10 and z is equals to 4. This is the first method we are using here, that is Cramer's rule. In this Cramer's rule, the three linear equations, three variables values are 7, minus 10 and 4. Now the next method is inverse matrix method. Same as these are the three linear equations. The first, this method is inverse matrix method. In this method, same as the matrix A is equals to the three linear equations has three variables. The first variable, second variable and third variable. The three coefficients are 1, 1, 1, 2, 2, 3, 1, 4, 9. And again the matrix X is equals to X, Y, Z. And the matrix B is equals to 1, 6, 3. Now again in the previous one already we know that determinant of A is equals to minus 3. or otherwise we want to find out 1 of 18 minus 12 minus 1 of, remove this row and this column to get 18 minus 3 plus 1 of 8 minus 2. 1 into 6 minus 1 of 15 plus 6, that is equals to 12 minus 15 is equals to minus 3. This is the determinant of A. Now here matrix A is equals to 1 1 1 2 2 3 1 4 9. It is in the form of A1 A2 A3 B1 B2 B3 C1 C2 C3. Now we want to find out the determinant of A1, determinant of B, A2, A3, B1, B2, B3, C1, C2, C3. We want to find out these values. Now first A1. A1 is equals to, now we give the symbols of these values. This is plus symbol, minus symbol, plus symbol, minus symbol, plus symbol, minus symbol. This is plus, minus, plus. How the symbols it becomes? Suppose first symbol, this one. This is first row and first column. So A1 is equals to minus 1 of first row and first column, 1 plus 1, that is equals to minus 1 whole square is equals to 1. So A2 is equals to minus 1 whole power of, this is second row and first column, second row and first column, that is equals to minus 1 whole cube is equals to minus 1. Suppose A3 is equals to minus 1 whole power of, this is first column and third row and first column is equals to minus 1 whole power 4 is equals to 1. We give the symbols like this. Now A1 means remove first row and first column. Remaining 4 elements, 2, 3, 4, 9. To get the determinant is 18 minus 12 is equals to 6. Now A2 has minus symbol, this one. Remove this row and this column to get 1, 1, 4, 9. Minus of 9 minus 4 is equals to minus 5. Now A3 is equals to, this is plus of, remove this row and this column, 1, 1, 2, 3. 1, 1, 2, 3. Determinant is 3 minus 2 is equals to 1. Now we want to find out the remaining values. B1 is here, it has minus symbol, minus of, remove this row and this column, B1, remove this row and this column to get 2, 3, 1, 9, 2, 3, 1, 9, minus of 18 minus 3 is equals to minus 15. Now B2 is equals to, here remove this row and this column to get the 4 elements are 1, 1, 1, 9. 1, 1, 1, 9. That is equals to 9 minus 1 is equals to 8. Now B3 is equals to, B3 has minus symbol, minus of, remove this row and this column to get 1, 1, 2, 3. 1, 1, 2, 3. So minus of 3 minus 2 is equals to minus 1. Now C1 is equals to, here plus symbol, this row and this column we want to eliminate. Now 2, 2, 1, 4. 2, 2, 1, 4. That is equals to 8 minus 2 is equals to 6. Now we want to find out C2. C2 has minus symbol, minus of, remove this row and this column, this row and this column to get 1, 1, 1, 4. 1, 1, 1, 4. That is equals to minus of 4 minus 1 is equals to minus 3. Now C3 is equals to, this one has plus symbol, remove this row and this row and this column to get 1, 1, 2, 2. 1, 1, 2, 2. That is equals to 2 minus 2 is equals to 0. Now, AX is equals to B. AX is equals to B. We want to find out X is equals to, A comes to this side, A inverse B. We want to find out A inverse here. A inverse is equals to, A inverse formula is adjoint A by determinant of A. Now find out the adjoint A. So A inverse is equals to, determinant A is minus 3, 1 by minus 3 of, adjoint A is nothing but this one, transpose. A1, A2, A3, B1, B2, B3, C1, C2, C3, transpose. That is equals to minus 1 by 3 of, the transpose is A1, A2, A3, B1, B2, B3, C1, C2, C3. Now minus 1 by 3 of, A1 is 6, A2 is minus 5, 1, and minus 15, 8, minus 1, 6, minus 3, 0. This is A inverse. Now A inverse into B. Now X is equals to A inverse into B. So X is equals to, A inverse is this one, minus 1 by 3 of 6 minus 5, 1, 6 minus 5, 1, minus 15, 8 minus 1, 6 minus 3, 0 into the matrix of B is 1, 6, 3. 1, 6, 3. This is 3 by 3 matrix and this is 3 by 1 matrix. So on multiplication to get 3 by 1 matrix. So X is equals to minus 1 by 3 of multiplication. First row into that one column. 6 into 1, 6 minus 30 plus 3 ones are 3. Now second row into that column. Minus 15 plus 8 6 are 48 minus 3. Now third row into column. 6 ones are 6 minus 18 plus 0. Now it becomes X is equals to minus 1 by 3 of 6 plus 3, 9. 9 minus 30 to get minus 21. This one, minus 18 plus 48 to get 30. This is minus 12. On substituting to get, so X is equals to, X, Y, Z values is equals to, this one by 3, minus 21 by minus 3 to get 7, minus 10, and this is 4. Therefore, X value is 7 and Y value is minus 10 and Z value is 4. These are the three variable values. This is inverse matrix method. Previous one is Cramer's rule. In that Cramer's rule, the three variable values are 7, minus 10 and 4. In this inverse matrix method, the three variable values are 7, minus 10 and 4. Now coming to the next method, that is Gauss-Jordan method. Gauss-Jordan method. Again, first same as the matrix A is equals to the coefficients of 1, 1, 1, 2, 2, 3, 1, 4, 9. And the matrix D is equals to the three variables 1, 6. Values of three linear equations are 1, 6 and 3. Now the augmented matrix AD becomes as 1, 1, 1, 1, 2, 2, 3, 6, 1, 4, 9, 3. In this matrix, the two elements becomes 0 by using the first row. This is row 1, this is row 2 and this is row 3. The two elements, these two elements becomes 0 by using the first row. Now R2 changes as R2 minus 2R1. Now R3 changes as R3 minus R1. Now the matrix AD becomes as 1, 1, 1, 1. First row as usual, and the second row R2 changes as R2 minus 2 times of R1. 2 minus 2, that is 0. Again 2 minus 2 into 1, 2. 2 minus 2, 0. 3 minus 2 into 1, 2. 3 minus 2, 1. And 6 minus 2 to get 4. Now R3 changes as R3 minus R1. 1 minus 1, 0. 4 minus 1, 3. 9 minus 1 to get 8. And 3 minus 1, 2. Now I want to change the R3, row 3. Row 3, this element becomes 0. So R3 changes as R3 minus 8 times of R2. Now matrix A becomes as first row as usual, and the second row also as usual, and the third row R3 minus 0 minus 0, 0. 3 minus 8 times of 0 to get 0. 8 minus 8, 0. 2 minus 32 to get, this is minus 30. Now again row 3. Row 3, both the two elements are, these two elements are divisible by 3. So R3 changes as R3 by 3. The matrix becomes as, so first row as usual, 1, 1, 1, 1, 0. This is 0, 1, 4. And the third matrix 0. 3 by 3 is nothing but 1. 0 by 3 is 0. And minus 30 by 3 is minus 10. Now the second row and the third row both are interchanged. R2 and R3 both are interchanged. To get matrix A becomes first row as usual, and the second row becomes third row becomes second row. Now it becomes 0, 1, 0, minus 10 and 0, 0, 1, 4. Now these three elements becomes 0. Now I want to convert these two elements becomes 0 by using second row and third row. Now this element I want to become 0. Now R2 changes as, R1. R1 changes as R1 minus R2. Now the matrix becomes 1 minus 0, 1, 1 minus 1, 0, 1 minus 0 is 1, 1 minus 10 is nothing but minus of minus 10, it is 11. Second as usual, and third also as usual. Now I want this element becomes 0 by using the third row. R1 changes as R1 minus R2. Now the matrix becomes as 1, 1 minus 0, 1, 0 minus 0, 0, 1 minus 1, 0, and 11 minus 4, 7. Second row as usual, and the third row is as usual. Now this one becomes as unit matrix of 3 by 3 matrix. These are the values of x, y and z. X is equals to 7 and y is equals to minus 10 and z is equals to 4. These are the three variables values. This is the Gauss-Jordan method. The first one is Cramer's rule, and the second one is inverse matrix method, and the third one is Gauss-Jordan method. In these three methods, the x, y, z having same values. X value is 7, y value is minus 10 and z value is 4. These are the three methods of matrix methods solving of linear equations in matrix method, Cramer's rule, inverse matrix method and Gauss theorem. Thank you.